Hello, in this episode we are going to create this coffee table made on the CNC. It was designed using FreeCAD and all the files were exported from FreeCAD, so I was able to drill the holes on my CNC. I can just go to this spreadsheet and let's say I want the coffee table to be square, 900 millimeters by 900 millimeters. And when going back to the 3D view, you can see it updated automatically. Let's say I want larger legs. I just go to the leg section, length and width. I will write 100 for each. You can see the legs are now larger. Let's make it a living room table. Let's give it a length of 2500, 2.5 meters. And now you can see we have an actual table. I will close this file and start from scratch so you can follow along and make your own parametric coffee table. If you don't have the time or don't want to recreate all these files, you can anytime go to my Patreon account and get the file from there. It's in the shop. So let's get started creating this coffee table. This is our empty document. I will go to the part design workbench and create a new body. I will rename it to leg front left, because the table will have 4 legs, of course. I will just create this one and then we will make copies. Let's save the file. We will need to also go to the spreadsheet workbench and create a new spreadsheet. That's all I need to do in this workbench. We'll move back to part design and to the 3D view, and in this body let's create a sketch. I will create it on the XY plane and I will create a rectangle with one corner in the origin. Now I should give some constraints to these lines so the rectangle is fully defined, but I don't want to just type some values here. I want them to be from the spreadsheet, so I will just write here leg section length and leg section width. I will give each dimension some values. Let's say 70. That's the actual coffee table that I shown you at the start of the video, so I will use those dimensions. It's 70 for each of them, so I will give one alias for each field, which is a variable name. I go to the top right corner and with the field selected I will just write leg underscore section length. Press enter twice. You can see it turned yellow. This means it has an alias, a variable name. Let's do the same for the second. And now I can go to my 3D design, to the sketcher, and select the bottom line. Press L to give it a length constraint. Press equal to enter the formula editor and just type spreadsheet dot leg section length. Press enter again, press enter again, and now it is 70 millimeters. I will do the same for this leg section width. Press enter until everything closes. You can see the sketch is green. This means it is fully constrained, as you can see in the left. I can now close it, and with this rectangle, which is actually a square but it's just a particular case, I want to pad it. So I also have to have another value here, leg height. There, let's go to the value field and give it an alias, leg height. And now I can go back to the 3D view, go to the sketch and press the pad button. Press this button or the equal key, I use the keyboard a lot, and type spreadsheet leg height. Now you can see it looks like a furniture leg. I will just go to the spreadsheet again, go to another column where I will write the general dimensions, give these 3 fields aliases. So we have one of our legs, we have its origin, and I want to be able to offset this using a value, frame offset. Give it a value of 30 millimeters and an alias frame underscore offset. So I need to change its position. Go to placement, position, and change the X and the Y. I will press on the expression, type spreadsheet offset. You can see it limited in the list. Press select it, press enter, do the same, press equal, spreadsheet frame offset, and now I have the X and the Y moved according to this value in the spreadsheet. We will make the other legs later in the workflow. And now I will create a new body and I will call it top. The top is the length and the width of the table. I will just create a new sketch, select the XY plane, press this button to view the section. It hides everything up to the sketch, and I will draw a rectangle with one corner in the origin. I will give it a length and press the equal sign, type spreadsheet table length, also a width. Press I this time because it's a vertical constraint, equal spreadsheet table width. And now I want to pad it, so I will go back to the spreadsheet and I will just write here top thickness 27 millimeters I used, and give it an alias also top thickness. I can now go to the top, select the sketch and press on the pad button. Here at the length I will enter an expression which is spreadsheet top thickness. The top is on the bottom of my coffee table. I have to move it upwards. I will just select it, go to placement position on the Z, press equal and type spreadsheet table height. If I show the origin of the top, you can see it's on the bottom of the top. So if I want this one to be the maximum height of my table, I will have to subtract the thickness of the top. I will just hide the origin again, select the top, go to placement, position, edit the formula, and minus spreadsheet top thickness. Now the table will always be the exact height that I've defined here, no matter what thickness I have the top. There's still one problem. You can see the leg is going through the top. Let me just hide the top, because the leg height is something that I've manually written. So I will go here, delete this value, type equal, and I will type the table height. You can see here I can also enter formulas, minus top thickness. Press enter. You can see it is automatically calculated each time I update one of those two fields. This one will also get auto calculated. It's a pretty useful thing to do whenever you do something parametric. Try changing the values along the way to test that everything is okay. Otherwise you might end up with an error in the end, which is much more difficult to correct than doing it now. What our table still needs are some rails, the short rail and the long rail. I will create another body, rename it short rail, and another one long rail. You can see that because I've also created the next body, the long rail, the short rail is no longer the active body, it's not bold, so I'll right click it and select toggle active body, and here I want to generate a sketch, and I will create it in the XZ plane because I want to define a section of the rail. Rail section height, rail section width. Also give them aliases, and I will give them some values, 70 and 27. And now let's draw a rectangle also from the origin. I always draw from the origin because the placement, it's much easier when you're creating parametric things. Making them with a corner in the origin is the easiest way to go. So I will give a length for this, press L, press equal, spreadsheet rail width. This will be the width of the rail. Select the vertical of the rectangle, press I for a vertical length constraint, press equal, spreadsheet rail height, and now the sketch is fully constrained. It's all green. You can also see here. Close it and pad it, but I want to pad it for a certain dimension which should be calculated based on the width of the table, the dimensions of the leg, and the offset. The rail should be equal to the entire length of the table, but I have to subtract 2 legs and 2 offsets. Type spreadsheet table width, and from this subtract 2 times leg section width, and add to this spreadsheet offset for the frame offset. I also have to use the multiplication symbol. Click OK. You can see it goes the other way, but that's not a problem. We can use the reverse checkbox, or much better, we will use placement. Placement is always parametric. Let's first show the origin of our short rail so we can see it. So any modification to the placement of the short rail is in the origin, in this corner. So I have to calculate the value of this corner when the rail is correctly placed. First of all, it's the X value, which will be this offset and the rail length itself. As you remember, its length was calculated. I can go to the pad, and here you can see a formula. Reusing this formula for the placement might be pretty difficult, so I'll just press Ctrl X and write a random value to be able to close this. Go to the spreadsheet and right here short rail length, go to the next field, go here, press equal, and press Ctrl V to paste the value. You can see it automatically removed the spreadsheet because it refers to itself, so they are not needed, and give it an alias short rail length. Press enter twice. You can see it is now yellow. Now I can go back to the pad and update the length, spreadsheet short rail length. It's much easier to use it this way. I can now go to its placement, go to the position, go to the Y, press equal, and now I have short rail length, and I will add the leg length. Leg section width is the actual dimension of the leg on the Y direction, and also add the offset. Now you can see on the Y direction the rail is just barely touching the leg here, so it is where it should be. Let's go back to the placement and move it upwards with the spreadsheet table height, but I have to subtract some things. First of all, it's the top height, the thickness of the top, and also its own height, because you can see its origin is on the bottom, so that's the point that I'm referring to. So I will have to subtract the rail height. Now press enter. You can see it is correctly placed. I will still have to move it on the x-axis, but I will do that after creating the holes for the connectors, because the position on the x, it's dependent on the holes for the connectors. Let's do the same for the long rail now. First of all, right click and toggle active body. Create a sketch. This time I'm going to use this plane. Press on the view sketch button. You can see it hid everything except what's from there on. I will create another rectangle, still from the origin, set its length, set its height, close the sketch. Now I will do the same for the long rail length. You can just go here, go to the content at the top, press Ctrl A to select everything, Ctrl C, go to the field that I want to modify, change the table width with table length, leg section width with leg section length, press enter, and now you can see I have the formula. I still have to give it an alias and go to the long rail in the 3D view, select the sketch, press the pad button, type enter, spreadsheet, long rail length, select it, press enter, close the pad dialog. We have to place this one too. Now I have all the elements defined. I have the long rail, the short rail, the leg and the top. For the other elements we will just copy them later. Now let's first start creating the holes for our connectors. I want the holes for this rail to always be in the middle of the leg. What I'm going to do now can lead to problems using the topological naming problem, the TMP, but since it's a simple design and I won't be changing anything from here, faces won't change when I change values. Of course, if I give way out of bounds values, everything will break, but that's not the idea. I don't want to make a fail-proof design. I want to make a design that I can use to create several things. I will select this face and create a sketch on this face. Press the view sketch button. I will just create two holes here for my connectors. I will select them both and press E for unequal constraint. Select one of them, give it a diameter of 8. You can see both circles updated. I will first select both center of the circles and press the V key to make these 2 points vertical. And now I have to place it in the middle of this distance. The easiest way is just to use external geometry. Select this edge, go to the line tool, make sure the point on line is valid here on the Z axis, move until the coincident point on point is viewable. Go again, make a second line coincident to this line, this external geometry. You can see they already have a horizontal constraint. What I need to do to make sure this is in the center is just select these two lines and press equal and make them construction geometry so they won't show up in the final sketch. And what we still have to do is to set the vertical distance from the top of the leg and the distance between the two holes. For that I will use some additional lines. First of all, let's create an external geometry to the top of the leg, and now let's create some lines from the center of the first circle to the top line, between the centers of the two circles, and another line from the center of the bottom circle, and stop it somewhere so we can have the same distance from the hole to the top and to the bottom of the rail. First of all, I will set a vertical distance constraint, press I and press equal to enter a formula. I will set it to the rail height. Now I can distribute these two holes equally on the rail, select the first line, the bottom line, and make them equal. Now whenever I move this circle, the bottom one also moves. They are equally spaced from the rail. I have to make these three lines construction geometry. Let's go to the spreadsheet and define the third column, the parameters for our connectors. I've made a mistake setting this to 8. I should have set it from the spreadsheet. So I will double click this constraint, press equal and type spreadsheet bolt screw diameter. I like to set the length of this line, press I to set a vertical distance constraint and set it to cam diameter, because from the center of this circle to here it's just the radius, it's half of the cam. I will make sure the hole for the cam won't get out of the piece no matter the diameter of the cam if I use larger cams. Everything is fully constrained. You can see here on the left. I will close the sketch and I will make a pocket. The length of the pocket should be bolt screw depth. Click OK, and I have to do the same thing for this face. I've made the exact same sketch for the second part of the leg and use this sketch to make two holes. And now I have the leg, the final shape of the leg. I'll create the connector holes on the short and on the long rail. Let's start with the short one. Right click on it, toggle active body. We have to drill some holes in the face of the rail, so I will select this face, click on the create sketch button. First make sure we have external geometry to these two lines, and I will create the 4 holes, just random circles here at the top and at the bottom. I want them to be equal, so I will select all of them and press the E key. Now they are all equal, and I want to give one of them, it doesn't matter which one, but just one of them, a radius or a diameter constraint. I will press equal spreadsheet cam diameter. This is the diameter of the hole, and I want them to be placed exactly the same, so these two, I will press the H key for a horizontal constraint. They are level now. Make the same thing for the bottom ones, and I will also select these two and set a vertical constraint, and the same for these two. I will only have to place 2 of them. Let's go down here and repeat what we did when creating the holes. Just make 3 lines, make these 2 lines equal, and the length of this one will be the cam diameter, because that's what I used when creating the holes in the legs. So the same I will use here. I have to make these construction geometry, and as you can see, these 2 are exactly placed on the left and on the right, just as the bottom ones. What I still can do is move them up and down. What I have to do is set a vertical distance constraint for one of the centers, so I will press the I button, and here I will use the bolt depth. This is the depth that the bolt will go into the rail. For this time I will have to select this point and this point, set a vertical distance constraint equal spreadsheet bolt depth, press OK, and now my sketch is fully constrained. I have the 4 holes. I will just close the sketch, make a pocket with this sketch, press equal to enter a formula, spreadsheet cam depth, and now I have the holes for the cams. I still have to make the holes to fit the bolts, so I will just go to one end, select this face and make a new sketch, and here I have to make 2 holes, give them a vertical constraint. I will select an external geometry to this line and make a horizontal distance constraint, pressing L. This should be equal to the spreadsheet bolt offset. That's the depth at which the bolt should be. Make the circles equal, make a radius for them equal spreadsheet bolt diameter, which is 8 millimeters in my case. Just make 3 lines. Make sure they are vertical, because if they are not vertical you might have some problems. I will also select an external geometry here and select the point and this line, enter a constraint point onto object or press O. Now I have to make these 2 lines equal, and the length of this line, which is a vertical distance constraint in this case, it's spreadsheet cam diameter. These green lines should be blue, so I select them, turn them to construction geometry, and now as you can see the holes are centered with the cam holes. Now I can make a pocket, press equal spreadsheet bolt depth, press OK. I've entered a bolt offset of 9 millimeters, but as you can see here in the drawing, it's called the A value, and in the table for my minifix 15 without rim, the A for the drilling depth of 11 millimeters is 6.5. Go to the spreadsheet and enter the correct bolt offset of 6.5 millimeters. I will have to do the same for this end of the short rail, and of course the same thing for the longer rail. So now that we have all the holes created, we still have to place these 2 rails to match the holes. I will select the leg, go to the view and set its transparency to 40 so I can see through it and make sure that everything is aligned. I will select the short rail, get back to the data tab and go to placement. I'll have to change the X. I will go to the short rail and go to the X, press equal, type spreadsheet frame offset plus spreadsheet leg section length is on this direction divided by 2. But when looking at what I changed, you can see that it takes this part of the rail, so I will have to move it back with its width, minus spreadsheet rail width. But now it's too far back because there is an offset for this hole, so I will just have to add that offset, and this should give our final formula. So it's spreadsheet bolt offset. They are perfectly centered. The holes in the leg will match with the holes in the rail. I will just go to the X value again, press on the formula editor and copy this value. Then I will paste it on the long rail in the Y field. I will have to change the leg section length to leg section width. Now you can see they are perfectly centered for this rail too. Our table is kind of ready. We still have to have 4 legs instead of 1. They are identical, just rotated, and we have to also duplicate these 2 rails. Let's start with a leg. For this I will go to the part workbench. I will press the mirror button, select the XZ plane, and you can see I now have this leg front left mirrored, and underneath it it's the initial leg. I will press F2 and leave the mirror here so I know it's a mirror even though there's an icon, and rename it leg back left. I will have to move it. I will select it and change the Y equal spreadsheet table width, and now it's perfectly placed. You can see that it takes into account the offset. Now I will have to do the same for the other 2 legs. I will just mirror this one for the right back leg. Press the mirror button again. This time I will have to use this plane, which is the YZ plane. I will select the last mirroring and mirror it again, this time on the XZ plane. Click OK, and you can see it here. I will have to move it again to the inside, press equal spreadsheet table width. I have all the 4 legs of the table. They all have the holes in the correct position. I still have to mirror these 2 rails, the long one and the short rail. Now I have an almost fully functional coffee table. What I still need to do is to connect the tabletop to the rails. I will use some threaded inserts for the top and Allen key screws for connecting. I will go to the spreadsheet and enter them. Here is the short rail, and I will draw some ovals on it, and I will select external geometry, outer lines of the rail. Now I will make these 2 equal, which will make equal diameter. I will give a diameter to the top one. It's spreadsheet rail top connector diameter. Also give a vertical constraint to this point and this point. We'll make the same trick with a line from the center to this line. Make sure it is horizontal, otherwise it doesn't work. To this line too, and select them, make them equal, select them again and make them construction geometry. Now this should be centered in the x-axis. Also set a vertical distance constraint equal to the spreadsheet rail top connector length. Do the same for the bottom one. They are still not constrained. Why? Because I still have to set a vertical distance. I will select the bottom point of the oval, the origin for the bottom one, press I again, press equal spreadsheet top connector offset. Now you can see it turned green. Do the same for this one. Select the top point, select one of the ends of the top line, press I for a vertical distance constraint, press equal spreadsheet top connector offset. So they are fully constrained. You can see they don't interfere with the connectors for the frame, so everything should be okay. If they would have interfered, I would have changed this value. I'll just close the sketch, make a pocket, select again the same face, make another sketch because we want the offset for the screw head to fit in here. I will select external geometry, the rounded parts of the initial ovals, and I will draw different ovals over these ones. Make sure the centers are constrained one on top of each other. Select one and the other end, make them equal, and set a constraint spreadsheet rail top connector offset diameter. Close the sketch, it's fully constrained, and now make a pocket, and the depth of the pocket should be from our spreadsheet again, rail top connector offset depth. So you can see the mirror of the short rail already has the holes, because that's the point of using mirroring. It's just creating a simple feature for one of them, and the other will have that feature too. I will have to make the holes for the long rails, and now you can see I have all the holes in the rails. We will have to make the holes in the top. For this I'm just going to right click on the top and make it an active body. Then I will select one round over in the end of these holes, and holding the control key I will select all of them at once and press this button, which is a sub-object shape binder. I will now hide the rails and the legs. With the top selected, you can see I have these yellow lines here. I will select the face, the bottom face of the top, and create a new sketch. The trick with a binder is that now I can use external geometry on those round over lines. Don't worry if they are moved around, it's just because of the perspective. I can use those holes as external geometry in my sketch. If they weren't part of this body, I wouldn't have been able to use them, but creating a binder allows me me, because the binder, you can see it resides in this body, I can now use that geometry to make features in my sketch. They are here, and create holes, which this time are round and should be in the center of the oval ones. So I will for now randomly place all the circles necessary to make the holes. Select all of them and go to this very useful tool, constrain auto radius or diameter. I'll just press equal, spreadsheet, top connector diameter, and as you can see, all the circles have now an equal constraint and a diameter constraints. It also added some constraints to the external geometry, but that doesn't actually matter because external geometry cannot be modified using constraints. You can see that they are actually blue constraints, which mean reference constraints, not driving constraints. I have to also select one of the centers of these half circles, set a vertical constraint this time, so they are aligned with the initial holes. I will do the same for this part, horizontal. Go here and select the center of my circles, set a vertical constraint, and do the same for this part and set a horizontal constraint. Now you can see they are all in line. All I have to do is set a distance for each of the circles, a length which is equal to spreadsheet rail top connector offset length divided by 2, because I want it to be in the middle. I will press Ctrl A to select the formula, press Ctrl C and repeat this for each of the circles. My sketch turned green, it is fully constrained. Now I can close it and use it to drill holes. The length should also be from the spreadsheet. It's top connector depth. I can close this now. So I will select the face again, press the sketch button. Now I will use the holes that I just created, press the external geometry, do this for all the circles, take them one by one and create a slightly larger circle for each of them. Make sure the centers are on top of each other. Select everything, click again on this very useful tool, auto radius constraint, top connector offset diameter, click OK. Close it. I will make another pocket equal to spreadsheet top connector offset depth, which is 2 millimeters. Now I will make the legs and the rails visible again. I will make sure the holes are centered. Here will be a bushing, and I will use M6 screws to connect everything together. The oval holes will be able to allow for some wood movement. Let's end this video by making everything transparent. On the view tab, set a visibility of 40. Here is the 3D view with a slight transparency, so we can make sure everything fits together as it should. Now let's try to modify the dimensions in the spreadsheet to make sure everything is parametric and changes correctly. Let's go first to the top thickness, give it a 50 millimeters thickness, make sure everything is okay, all the holes are aligned. Also, let's change the section of the legs. Let's make them 100 millimeters by 120 millimeters. I will make them different to make sure I used the correct reference when setting the rails, and as you can see, everything is okay. If I would stretch the dimensions too much, probably these two would be one on top of each other. I will run into the topological naming problem, but the idea of this way of doing things, it's not to be fail-proof, it's just to be useful. Thank you for watching, and see you next time on the CAM workbench when we will create the path to drill all the necessary holes on the CNC.